Have you ever thought about traveling through time? A fascinating concept, isn't it? Time travel, the idea of journeying into the past or future, has been a staple in the realm of science fiction, from H.G. Wells's The Time Machine to the blockbuster Back to the Future series. These narratives have captivated us, allowing us to explore different eras and possibilities. Yet beyond the realms of fiction, time travel remains a topic of heated debate and intrigue among scientists and theorists alike. Time, often visualized as a straight line or a ceaseless river, is much more complex than we might think. In reality, it's considered the fourth dimension, intertwined with space in what Albert Einstein called space-time. This space-time fabric is the canvas upon which our universe paints its existence. It's not just something we move through, but rather it's a fundamental part of our universe's structure. Now consider this, we are all time travelers in a sense. Each second that ticks by propels us into the future. But what if we could control this journey? What if we could move back and forth along the timeline, just as we move in space? This tantalizing idea has intrigued humans for centuries. Imagine being able to witness the construction of the pyramids or take a peek into the world 500 years from now. However, it's not as simple as hopping in a time machine and pressing a button. Theoretical physics suggests that to travel through time, we might need to manipulate space-time itself. This could involve concepts like wormholes and black holes, which are themselves subjects of intense scientific scrutiny. So we're left with a question: is time travel just a figment of our imagination, something confined to books and movie screens? Or perhaps could it be a real possibility, a frontier of science waiting to be explored? These are the questions that continue to drive our curiosity, pushing the boundaries of human understanding. So is time travel just a figment of our imagination, or does it have some basis in reality? Does science support the idea of time travel? Let's delve into that question. Our exploration begins with a man named Albert Einstein. Einstein, a physicist, gifted us with the theory of relativity, which fundamentally transformed our understanding of space, time, and gravity. Central to this theory is the concept of space-time, the four-dimensional fabric of our universe. This concept opened the door to the tantalizing possibility of time travel. You see, according to Einstein's theory, time and space are interwoven, but they're not rigid. They can be influenced by things like speed and gravity. This leads us to the phenomenon of time dilation. Time dilation suggests that time doesn't tick at the same rate everywhere. It's slower where gravity is strong, and it's faster where gravity is weak. And it's not just about gravity. Speed plays a part too. The faster you move, the slower time passes for you relative to someone who is stationary. Now, hold on to your hats, because this implies that if you could travel close to the speed of light, you could theoretically leap into the future. You'd age slower than the folks left behind on Earth. So when you return, you'd find everyone else has aged faster, effectively propelling you into the future. But what about the past? Can we travel there? This is where wormholes come into play. Wormholes are theoretical passages through space-time, like tunnels. If they exist, and if we could traverse them, they might allow us to travel vast distances in the blink of an eye, or even journey into the past or future. However, it's important to stress that these are all based on theoretical physics. We've yet to observe a wormhole, and we certainly can't travel at speeds anywhere near the speed of light. So, theoretically, time travel is possible, but what about practically? Let's continue our journey to find out. What are the challenges that stand in the way of time travel? As captivating as the concept of time travel may be, it's far from being a walk in the park. The challenges are colossal, ranging from the technological to the theoretical. Let's dive in, shall we? First up, the technological hurdles. Imagine needing to harness the power of a star or manipulating the fabric of space-time itself. Even with our most advanced technology, these feats are currently beyond our reach. The energy required to create a wormhole or to propel a vehicle near the speed of light is simply astronomical. We're talking about energy levels that make our most powerful nuclear reactors seem like a child's toy. And let's not forget about the need for exotic matter with negative energy density to keep these wormholes from collapsing. As you can see, the technological challenges alone are enough to make the most optimistic scientist pause for thought. Then there are the paradoxes. Oh, the paradoxes. Perhaps the most famous is the grandfather paradox. Suppose you travel back in time and accidentally prevent your grandparents from meeting. This would mean you could never have been born to travel back in time in the first place. Confusing, right? This creates a logical inconsistency that has puzzled scientists and philosophers alike. Some suggest that such paradoxes could be resolved through the concept of parallel universes or alternate timelines. But these ideas, while fascinating, are yet to be proven and are largely theoretical. They bring with them their own set of challenges and complexities, and we're still a long way from understanding them fully. It's clear that time travel, as we understand it today, is fraught with practical and theoretical challenges. We're grappling with immense energy requirements, technological limitations, and mind-bending paradoxes. And while we've made immense strides in understanding the universe, time travel remains an enigma. The practical challenges and paradoxes make time travel a tough nut to crack. What does the future hold for time travel? As we venture forth, the realms of quantum physics and cosmology appear to be our best guides. There's a growing belief that these complex fields could hold the keys to unraveling the enigma of time travel. Why? Because they challenge our traditional understanding of the universe and tease us with tantalizing possibilities. Quantum physics, with its particles that can be in two places at once, suggests a universe far more mysterious than our everyday experience. Cosmology, with its vast scales and mind-bending concepts like black holes and wormholes, hints at shortcuts through space and time. The future of time travel is a frontier of the unknown. It teaches us the importance of keeping an open mind. Today's science fiction could very well be tomorrow's science fact. Time will tell if time travel remains in the realm of fiction or if it becomes a reality. Until then, we can only dream and ponder the possibilities.
Thanks for watching. Please subscribe by pressing button below.